Perfect. Let's take a look at another example here. We're going to use line segment formula to evaluate the following. In this example, I ask you to find the line integral of y squared dx plus x dy along curve C, and curve C is defined as line segment from the points -5 and -3 to stopping point 0 and 2. So since you have a line segment, we are going back to elementary calculus. We had a nice formula for line segment. R of t is defined as 1 minus t, r sub 0 plus t, r sub 1, and t was bounded between 0 and 1. We can convert these 2 points into vectors. So you have initial point, you have terminal point, you can convert them into vector form. RT is equal to 1 minus t. In the vector format, this point, connecting this point to the origin, gives you -5 and -3. Please note the symbol and notation that I'm using right now. I'm using a vector. R sub 0 bar is a vector, plus parameter t times the second vector, connecting 0 and 2 to the origin, which gives you a new vector, 0 and 2. So this line segment can be written as, we can just distribute 1 minus t, distribute t, and combine these together. It becomes vector -5 plus 5t, -3 plus 3t, plus the second vector, 0 and 2t. You're going to add the first components and add the second components, and your line segment in parametric form gives you the first component, -5 plus 5t, and -3 plus 2t plus 3t plus 5t. So this is your xt, and this guy is your yt. You can easily find dx, dy, and convert everything into t. Again, you have one integral, but you have 2 variables. You have to get rid of these, introduce a new parameter here. This integral is equal to the integral y squared, and you also have x. You need to find dx, and you need to find dy. dx is equal to 5 dt, and dy is also 5 dt. Very good. Y squared, -3 plus 5t to the second, dx, which is 5 dt, plus x, which is -5, plus 5t, and dy, which is 5 dt. And as you know, t is bounded between 0 and 1. So our integral, which was written in x and y, is now all converted into t. We can easily find this integral. If you use u to be -t plus 5t, du is 5 dt. So this guy becomes a third, -3 plus 5t to the third, 0 to 1. The same here. If you take this guy as your u, du is 5 dt. So here you have plus a half, -5 plus 5t to the second, 0 to 1. If you simplify this, you get a third, -3 plus 5t. Let me put this here. Minus, if I plug in 1 here, I get 2 to the third. And here I have yes, that's correct. We had everything in x and y, and we converted everything in t. Note that we have one integral in two variables, so it must be either x in terms of y in terms of x, or a new parameter, this formula that you learned in elementary calculus, and converting everything into t, and then taking the integral. Here, let me show you. You can say that my u is equal to 5t minus 3 du is 5 dt. So this integral can be written as the integral of u squared du, which is a third u cubed, but u is 5t minus 3, so I'm going to write down 5t minus 3 to the third power, and t ranges between 0 and 4. The same for this guy here. I can take u to be 5t minus 5, and du is 5 dt. I already have u and du, so this guy becomes integral of u du, or a half u squared, but u is 5t minus 5 to the second, and t is bounded between 0 and 1. So here I have a third, and if I plug in 1, I get 2 to the third. If I plug in 0, I get negative 3 to the third, plus a half. If I plug in, for example, 1, I get 0 squared. And if I plug in 0, I have negative 5 to the second. So if I simplify this guy, I should get negative 5 over 6. This is my line integral.